Welcome back to this online training series presented by Black Tech Academy. We're talking about UML diagrams. And last lesson I gave you some game on what it is, why it's important, and how to create use case diagrams. Well, today we talking about class diagrams and object diagrams and sequence diagrams and state diagrams. Oh my. And the biggest thing that I want you to kind of understand about this lesson is this is more geared towards software engineers, people who actually write code day to day, or maybe even testers or analysts. So if you've never written code before, this might be a little bit complex for you, but stick around. If you need to, just review this lesson over and over again till you get it. And again, if you've got any questions, I'm here to the end. You can ask them in the chat box. Now, class diagrams. They're represented by these little rectangle squares, and there's three sections. There's three parts to each of them. I'm going to zoom into one of them. The first section is the name of the class at the very top. The second section is its attributes. So how do we describe that class? And the third section is the methods or the functions of that class. All right. So in the attribute section, we've got minus signs. Those minus signs represent visibility. Now, we'll get to visibility in a second. Right next to visibility, we have the name of the attribute, user ID, password, login status, register date. Those are the names of the attributes. Then we put a colon right next to it, and then we give its data type. Now, there's different types of data types. String represents a series of characters. Obviously, data is a date. You've got integer. Boolean is a true and false statement, that sort of stuff. So you give a name, a visibility, and then also its data type, right? Now, the third section are methods. On the left of the name of the method is, again, the visibility. In this case, there's a plus sign right next to verified login. We've got parentheses next to the name. They're optional, but they can represent the different types of parameters that a method can accept. We call that a signature. Again, there's a colon, and then you can actually represent the return value of that method. Again, it's not required, but in this case, we see bool, which represents a true or false. Okay, so that's a class. The name of the class, the attributes, and the methods, along with its visibility. So back to visibility. What is visibility? Well, visibility is accessibility in an application. So if you see a minus sign, that means that that attribute or that method is private. And that just basically means that no one else can access that attribute or method except for that particular class. Okay. The next one is public, which is represented as a plus sign. That basically means that anyone can access that from the outside world. The third one is protected, and that's represented as a pound or a hash sign. That basically says that only this class and parents above it can access it. So if that particular class is inheriting from another class, then you can access that attribute or that method. Okay, the final one, the fourth one, is default, and that's represented as a tilde sign. And I want to kind of share with you a little bit about classes, right? You can create what's called a package, and a package in software is basically a collection of classes. So in that package, you have a number of classes, and you can set the default visibility inside the package. And then you can say, okay, this particular class, this attribute, and this method, just give me the default or whatever, the package says. So you'll use a tilde to represent that. So they're not used quite often. Normally, you're going to be using either minus signs to represent privates or plus signs to represent public. Totally up to you and how you build your software application. Again, just to recap, three parts to the class: name of the class, attributes, and then methods, of course, with its visibility for each of those. Next, we're going to talk about relationships. There's 4 different types of relationships. I'm going to zoom out here so we can kind of see a little bit more of this class diagram. There's 4 different types of relationships. We've got inheritance, association, aggregation, and composition. Let's start with inheritance. So user is essentially a parent in this case, and customer and administrator are pointing to user. You can call those the children. That essentially represents an inheritance relationship. Customer is inheriting everything that a user has. Administrator is inheriting everything that a user has. So you don't have to repeat yourself. there is a special little process called don't repeat yourself when it comes to software development. Dry, we call that. And this is an example of dry, where you don't have to repeat yourself. So you get all of the benefits of a user if you're an administrator. Same thing for a customer. We call that inheritance. Now, user is also a type of abstract class as well. So inheritance usually involves a sort of abstract class. And in this case, that's what that represents there. The next one is an association, which is just basically a line between two classes. There's nothing special about it. And the relationship, you can give it a kind of name. It doesn't really matter. There's no real tie to the two classes other than that sort of association. It's just an association. Very simple. The third one is an aggregation. That's represented as an open diamond. And so aggregation is basically saying that this particular class can live outside of the whole. It can exist outside of the whole. It's part of a whole. It can be, but it doesn't have to be. Okay, so that's very cool because some things can live outside of of the whole in applications, and we represent that as an open diamond. The last one is a composition. Composition basically says it's the opposite of an aggregation. It says I can't live outside of the whole on my own. So shopping cart is an example of a composition. The relationship between shopping cart and customer, that's an example of a composition because we see that the diamond is connected to customer, which basically means that the shopping cart cannot live on its own. So if the customer gets deleted, the shopping cart cannot exist either. Same thing for an order. And even order in this case has its own particular composition relationships between shipping info and order details, right? If the order gets deleted in the database, the shipping info and the order details can't exist on their own. They need an order to be tied to. That's composition. Just to recap one more time, we're talking about relationships. Inheritance, number one, right? So that's user, customer, and administrator. We represent that as an open arrow. The second one is association, which is essentially just a line between two classes. The third one is aggregation. We represent that as an open diamond, which basically means that this class can exist outside of the whole. The last one is composition, which basically means that this class cannot exist out of the whole. Who's with me so far? Just go ahead and say something in the chat box. That's great information. Okay, what do the numbers mean? Okay, cool. Yeah, so we're getting to that next. The numbers represent multiplicity. Multiplicity is a fancy word for what is the numerical constraints between the relationship. So there's 6 different types of multiplicity constraints. You've got one-to-one, which basically means there's a one-to-one relationship between this class and that class. You've got a one-to-many. This class can have a relationship between many classes. You've got a 0-to-1, and that's really optional. So you can say you can have one relationship or none. You have an in relationship, which is basically the number of relationships. So that's an exact amount. You have 0-to-many. And then you also have many-to-many, which is a number, a range of numbers. So this number to that number, right? So in this example, we've got shopping cart and customer. That one represents multiplicity between the shopping cart and the customer. A shopping cart can only have one customer. And the 0 ... star represents the 0-to-many. So a customer can have many shopping carts or none at all. Right. Another example is here. A customer can have many orders or none at all, and an order can only belong to one customer. Right. And again, just to kind of backtrack here, these are composition relationships, so an order can't exist on its own without having a customer. Likewise, we've got a one-to-one relationship between order and shipping info. Here is a one relationship, so order can only have one shipping info, and shipping info can only have one order. And then order has an order details, and then order details belongs to one order. Again, in the relationships, you can give them names. So this has a right here. You can give that a name. It's very common for associations as well. And that's it. So you've learned a little bit about class diagrams. Now let's go ahead and talk about object diagrams. Wake up, wake up, wake up. We're talking about object diagrams next. We just talked about class diagrams. Now we're on to object diagrams. What's the difference? Okay, so class diagrams limit us because you can only create one class in a class diagram. Whereas in an object diagram, you can create unlimited instances of that class. So let me backtrack here for a second if I lost you. Classes represent models of something, and objects represent instances of that something in the real world. Okay? So classes is just a blueprint, but objects are the real thing. So classes limit us, but objects are unlimited, right? So in object diagrams, we create objects, but we want to make sure that we're only showing the most impactful objects in our diagram, because we can't actually represent all of them. If we have a very large application, it would be silly to attempt to do so. So instead, we want to only show the most important ones. Now, I want to share this with you. Object diagrams conveys objects and links instead of classes and relationships. Okay, so there's a line between company, an instance of company represented as C, and D1 department and D2 department. Those are links, right? The next thing is attributes. So we actually want to set a meaningful value for every attribute, and that's important. You can see in this example, D1, the name is sales. D3, the name is US sales. D2, the name is R&D. And so you want to give every value a meaningful value, right? And you only want to show the most important objects in your object diagram. Finally, if you need any kind of notation, you can add notation for objects. So person is a manager. You see the manager note there. Or you can even clarify, links between two objects. Yeah, so that's pretty much it. Object diagrams are not difficult to understand. And the biggest thing is you want to showcase the most important ones. You don't want to show them all. Typically, you want to show the ones that are, always in the application, always running, or has the most impact in your application, usually like a customer or an administrator or something to that effect. Next, we're going to move on to sequence diagrams. This is my favorite. Now, there are two different types of sequence diagrams. The first one is UML based, which is the standard, and the second type is code based, which is pretty much, if you want to look at code in a deeper level, you can create a sequence diagram for that specific piece of code. We're only going to talk about UML based sequence diagrams in this lesson. And you can do your own research on the code-based diagrams. Now, there are many different types of benefits for sequence diagrams. One is that it represents the details of a specific use case, right? So in our previous lesson, we talked about use case diagrams. We can deep dive further into that use case and create sequence diagrams that better explain what is going on. So sequence diagrams, what are they? Well, they show the interaction between different parts of a system or the sequence of events that happen in order. So they're really focused on what happens first, then what happens next, and what happens last. And so you can think of a system as a whole. What it does is it breaks that system down into different parts. And so one of the best benefits that you get out of sequence diagrams is it's able to create further detail about a specific use case. Remember in lesson 1, we talked about use case diagrams? Well, for sequence diagrams, you can deep dive further into those different use cases. Now, before we actually create a sequence diagram, I need to share with you some of the basic symbols and components of a sequence diagram. Now, to create sequence diagrams, we need to understand the different symbols and components. So we'll start with the actor symbol. Again, we learned this in lesson 1. Actors are external to the system and they interact with it in some way. So we've got the actor symbol. The next symbol that I want to share with you is an object symbol. And an object symbol essentially represents the object in the system, right? So we learned about object diagrams, which is an instance of a class. And so in this particular diagram, in sequence diagrams, we don't show class attributes or object attributes for that matter, right? So it's just a rectangle, if you will. The third one is lifeline symbols. So lifeline symbols represent the passage of time. So the further down that lifeline symbol is, the longer the time for that particular component or process or sequence of events, right? So they start at the top of the symbol and they work their way down. And again, the longer the symbol, the longer it takes for that to process. Who's with me so far? All right, so a question, what's the colon? Again, the colon is representing the object diagram. So you can give this object a name. We could have put a U in front of the colon or named it whatever we wanted to. It's a good question. So the next symbol we'll talk about is the activation box. Activation boxes represents the time needed for an object to complete a task. So the longer the task will take, the longer the activation box becomes. And we'll see an example of that in a second. Next, we've got conditional symbols. So option loop is one symbol where there is a loop, and alternative symbols represent an if-else statement, which those are typically mutually exclusive. So if this happens, then this condition is true, else this condition is true. Those are pretty much the common types of symbols in sequence diagrams. Next, we'll talk about how we express data sent from one object to another object. We call that messaging. So data sent between two objects is a message. So one object calls another object and sends a message. And in sequence diagrams, we express messages as arrows. Now, in programming, there are two different types of ways to send data or data, depending on who says the word: synchronous and asynchronous. Synchronous essentially means that data is locked between the two objects and nothing else can process until that data is completely sent to the receiving object. Essentially, it basically means the application or the system is locked for a period of time, right? So that data needs to be sent. It needs to be what we call autonomous from start to finish. All right. Asynchronous means that the data is being sent and the system is not locked. And so you can get very dynamic applications if you're sending data between two objects in an asynchronous format. So back to message symbols. There are different types of message symbols. We've got synchronous message symbols. We represent those as solid arrowheads. Right? So the sender must wait for a response to a message before it continues. And we've got asynchronous messages, which is represented by a solid line with a lined arrowhead. They don't require a response before the sender continues. All right? So when data is sent back to the sender, right? So the receivers received the message, they did something, they processed whatever data they needed to process. They're going to send a return message back to the caller. And we represent that using return message symbols. And we've got asynchronous return messages represented as dotted lined arrowheads pointing back. The same applies for reply messages, which is essentially saying, hey, we just want to reply back to the sender in some fashion. That's the same as an asynchronous return message symbol. They're represented as dashed lines. Okay. And we've also got two special types of message symbols. One is called an asynchronous create message symbol, which allows us to create a new object. So it's creating a new object, and when that object is created, it's created asynchronously, so the sender doesn't have to wait, or the receiver doesn't have to wait, rather. And finally, we've got a delete message symbol, and that's expressed as a big X on the lifeline. So we've got a sequence diagram in front of us. In this example, the sequence diagram is representing a patron who is putting money inside of his bank account through an ATM machine, right? So our use case is patron is adding money into his bank account. Now, we've got the different types of symbols expressed in this diagram. We've got our actor, patron. We've got our different object instances. We've got ATM, control, and database. Okay. We've got the lifelines that are pointing from those actors and objects, represented as these dashed lines right here. And we've got our messages. So the first message that needs to happen is the patron needs to, submit their card inside the ATM. Right. So that's expressed as this synchronous call, the synchronous message here, from patron to ATM. And the ATM then immediately calls the control system to verify that PIN. And there is a response back from the control to the patron, which is represented as an asynchronous call back. And in this case, we've got an invalid PIN, right? So if there is an invalid PIN provided by the patron, then the ATM will then eject the card back to the patron. And so these activation boxes, again, represent the length of time it takes for these particular tasks to be completed. So we can see that verify PIN was pretty short, and the time it took for the control system to send back the reply back to the patron saying that they've got an invalid PIN is also short. Okay. Now, we've also got examples where the ATM is sending the request amount back to the patron. This is a reply message back to the patron, so the patron needs to be able to submit what kind of amount they want to deposit. So the actor will send a message back to the ATM and enter the deposit amount. The control system will then deposit that amount into the database and then update the account. Or if the patron is withdrawing money, they can do so as well. And if there are insufficient funds in the account, again, the database will tell the control system and then the ATM that the patron doesn't have sufficient funds in their account. Finally, at the end, the ATM will conclude whatever transaction the patron requested. So this is a fantastic example of messaging between different objects and sequence diagrams as a whole. Now, you don't want to bog yourself down on sequence diagrams. The best way to create them is to focus on the most important use case diagrams and then build your sequence diagrams from those. So you only want to create these for the most important pieces of your application. All right, so that was a lot to digest. Are there any questions on sequence diagrams? Why isn't there a reply back from database to the patron showing them the amount that was deposited? That's just the example in this case didn't show that, right? But if we wanted to show that reply message, we would simply put an arrow, a dashed arrow pointing back to the patron with the reply message. That's a great question. What if you had more objects? Yeah, so you can add as many objects as you need to on sequence diagrams. Great, great. No more questions. You guys are good, man. So the last diagram we're going to talk about today is state diagrams. And state diagrams show the different states of an object. Those states are controlled by internal events inside the system as well as external events outside the system. And these are really useful for reactive systems and reactive objects, things that react to events. You get to see the different states for that object. I've got an example very similar to our ATM example where we're swiping our card and we're putting in a PIN number and verifying that it actually is legit or if it's rejected. So in state diagrams, we start with the start, which is usually represented as a filled in dot. And then we have a transition between start and waiting for PIN. So waiting for PIN is a type of state. So we're transitioning from start to state. And that transition is reflecting as a card swipe. So you can actually name the different types of transitions. Then we've got a double arrow pointing to and from waiting for PIN and PIN verification. So when we're entering our PIN, that transition is PIN entered. And PIN verification sends another transition called PIN authentication to user identified, which is the final state. And the final state is represented as a filled in circle with another line around it, a border line. So if that user is identified, then it is successful. And at any time, if the PIN is unable to authenticate, it sends another transition back to waiting for PIN and says that the PIN is rejected. This is a pretty simple example of a state diagram, but you can see that it can get pretty complex depending on the type of object and its different states you're trying to represent. Well, that completes our lesson on UML diagrams. Give yourselves a round of applause for sticking around. You know what I'm saying? This is going to be great skills to have if you're a software engineer or an analyst or a tester. You guys are getting some free game right now. So you can walk up to these companies and say, hey, I know UML Diagrams. What's up? So, final lesson is on Friday. I want you to continue your education outside of this program. I want you to watch YouTube videos, learn as much as you can about the diagrams we talked about today. On Friday, I've got a very special treat. I'm going to be sharing with you an interview with one of my customers, and he'll share with you how cool and how powerful UML diagrams were for his business. So, I'll see you on Friday. Peace out.